Well, good morning, good afternoon, or good evening to all of you out there. Welcome to our third in a series of 2022 Tech Talks from EdgeX Foundry. My name is Jim White, and I'm going to be presenting today how to build a device service. I should, let me back up one slide there. I should make aware for everyone as well that the materials you're going to see here today, both the slides, the code, and eventually the recording of this session are all available on our wiki site. So you go to wiki.edgexfoundry.org. You can just do a search for Tech Talks, or you can find it at this location here, Display FA, EdgeX Plus Tech Talks. We will also have this uploaded on YouTube a little bit later on here this week as well. Again, my name is Jim White. I'm from IoTech Systems. I'm the CTO there. We're an edge software company that produces a commercial implementation of EdgeX Foundry called EdgeXpert, but we also provide some other products. I was formerly at Dell, where I started EdgeX Foundry, and currently today serve as the technical steering committee chairman, and kind of the ad hoc unofficial lead architect, at least for a little bit longer. We've got a new TSC coming in here shortly, and they're going to take over and carry the project forward. As I mentioned, this is one of a series of talks that we're providing here this summer on EdgeX Foundry. EdgeX 2.0 is out. In fact, we just released Kamakura, which is version 2.2, and we thought it would be good to refresh our Tech Talk series that have been out there on YouTube for some time. So we've got a couple that are already in the books. You can find those out there on YouTube or on our wiki site. We did a Getting Started Tech Talk a few weeks ago, and then Lenny Goodell from Intel provided one on building an application service just last week. Today's talk, obviously, building a device service. A little bit later on here next week, we're going to have James Butcher provide a tech talk that's kind of a supplement to the one you're going to hear today. It's about how to build a device profile, and you'll learn more about device profiles today. But if you're using an existing device service as opposed to building a new one, you might want to tune into that one. That's going to help you essentially configure an existing device service with a device profile. And then later on this month, we're going to have Canonical present how to get started with Ubuntu Canonical Snaps and EdgeX. Okay, in terms of our agenda here today, we're going to try to give you an understanding of what EdgeX device services do, what role these microservices play, how to get an existing device service up and running. That's actually pretty straightforward. Then we're going to learn how to build your own device service, the tools you need to create it, how to actually get the device service SDK to create one, how to create a custom device service from the example code that's in the SDK. We'll show you how to run it, how to test it, explore it, then we'll give you some more resources. I do have a question coming in on the channel here too from David Flores asking if the recording will be made available. And yes, it will. Again, everybody, the recording will be made available both on our wiki site as well as through YouTube. So again, the focus of today's discussion is going to be on device services. So I've got them highlighted here in our architecture, the red boxes you see at the bottom. That is, EdgeX project comes with a number of device services already available to you. No need to create them if one of your device services needs to talk a protocol that you see highlighted here, things like SNMP and REST and Modbus. If you need to create a new one, if what EdgeX provides in terms of device services and its connectivity to things out there is something that you find EdgeX doesn't have for your need, for your use case, that's where you're going to use the SDK, and that's what we're going to do today. Take a look at using the SDK to create a brand new one of these device service boxes, if you will, here. By the way, if this diagram, the architectural diagram of EdgeX is a little bit foreign to you, if you're really not sure of what place an EdgeX device services plays in the architecture, I'll talk a little bit about that today, but I would also encourage you to take a look at the video we did 2 weeks ago on getting started with EdgeX. We go into more details about the overarching architecture and how device services and other services play as part of this microservice environment. So what exactly does a device service do? It is one of our EdgeX microservices. Essentially, it is what connects to and talks to the quote unquote thing of Internet of Things. It might be some sort of a sensor out there. It might be, for example, a vibration sensor, a thermostat, could be a camera, a moisture sensor, you name it. There are all sorts of quote unquote things in this edge world. That's what our device services are really meant to do, is serve as a mechanism to connect EdgeX into or with one of those device or sensors. They could be a virtual sensor. For example, you could get weather off of the internet and pass that data into EdgeX. That is a sensor from the perspective as EdgeX is concerned. It's all about feeding data into this edge environment. How you get that data, where it comes from, entirely up to you. In fact, we've seen people stack instances of EdgeX, and the device service may communicate with another instance of EdgeX running on, for example, a gateway. From an EdgeX perspective, it's all about, that is a device service, is all about really obfuscating where the data is coming from, but making it available into other layers of the system. Now, typically, a device service is going to speak a particular protocol. It may speak Modbus or BACnet, or you can see some of the protocols listed there. Traditionally, we built EdgeX so that it's speaking a lot of the operational technology or OT types of protocol, but it doesn't have to. Again, it could communicate via MQTT or REST, or maybe one of the cellular or Wi-Fi types of connections, something like BLE, wireless, if you will. The type of device service is traditionally built around a particular protocol that a thing speaks, and you build that device service to be able to communicate via that protocol. And that's what provides the translation into EdgeX for that thing or that sensor. Now, the device service serves a number of roles, but there are two primary jobs that it has. It's first responsible for getting, or if you will, collecting sensor data from a sensor or device. Now, I say sensor data here, I should probably put that in air quotes. A sensor, again, could be anything. It could be a physical sensor like a moisture sensor, or it could be maybe data you're picking up off the internet or from some other application. But a sensor in this sense is all about where the data is coming from. EdgeX helps to collect that data. And in the case where it's coming from some sort of industrial piece of equipment, an OT device, it will speak the protocol of that device in order to get it. But it also serves a second very important role, and that is to be able to set or actuate the device or sensor on behalf of EdgeX, or whatever is using EdgeX to communicate to that sensor or device. So for example, if we had a thermostat in place in our homes, for example's sake, EdgeX first job is to get data from that thermostat, typically something like the temperature and humidity from that thermostat, but you may need to set the cooling point or heating point on that thermostat as well. That's the actuation role that a device service can play as well. So if you will, a device service communicates in two directions: getting and setting of data, or in other terms, collecting and actuating on that device or sensor. Now, a device service has other jobs as well. We don't want to minimize this and say that device services only does get and set. It also has other roles. It'll take the data and transform the sensor data into an EdgeX format so that it can give it out to other EdgeX services, and or ultimately give it out to other applications that are using EdgeX to communicate with sensors or devices. It helps to monitor those sensors and devices and determine when they're connected and functioning well, or when they may be offline or having some sort of issue. It also is there to help what we call provision or discover new sensors or devices. It can do that in kind of a static way, meaning you provide the EdgeX device service information about what to and how to connect to some sort of sensor device, and then it will quote unquote provision it, or if you will, initialize it and get it ready for getting and setting. Or it might be able to do that in an automated function. In other words, it might scan for a particular address space and bring on new sensors devices based on that particular device or sensor's capabilities, and based on whether or not those are something that the EdgeX mechanism can avail itself to be able to provision. An automated way, no human intervention, no static configuration necessary to do that. In EdgeX, we have a number of existing device services that are already out there, as I mentioned. We have some for Modbus, BACnet, SNMP, MQTT, REST, GPIO, RFID sensors, which are based on LLRP protocol, OnViv camera services, USB camera services as well, CoAP and Grove. As you can see, a fairly substantial list of existing device services that already allow EdgeX to connect to a number of quote unquote things out there. Some of those are written in C, some of those are written in Go. Typically, the device service is written in a language that is most easily used with the libraries and connectivity options available for those particular protocols. Some protocols are very much more industrial space driven, and those are typically written in C, whereas others, especially some of the wireless protocols, tend to avail themselves of more modern languages like Go. The language doesn't matter, because typically when you're using one of these device services, you're not having to touch the code itself. All you're having to do is what we say configure, or if you will, provide some details to that device services that device service about how you need to work with, connect to, and exchange information with that sensor device. So that's the low code or no code approach, using existing EdgeX device service to communicate with things that are already out there. This is going to be a topic for some of what you'll hear in next week's Tech Talk, as James Butcher will tell you more about how to, if you will, configure, or more precisely, provide a device profile for existing device services that exist out there. In addition to these already existing device services for quote unquote things, we also provide a virtual device. The virtual device is a means to simulate other sensors or devices. If you download and work with EdgeX right straight from the examples that we have out there in our GitHub repository, what you'll find is that it often is set up with a virtual device in order to simulate data flow so that you can start to play with and start to understand EdgeX as if it was connected to real sensors or devices. That virtual device can also be used to help drive tests. It can also be used to do things like check out just the normal flow of a device service to begin to understand how to build a device service. Finally, there are some third-party providers of additional device services out there. My company, for example, IoTech, provides a number of commercially available device services to connect up and be used with EdgeX. These typically cover proprietary protocols, things like Profinet, which are something that from an open source perspective, we couldn't do as a project. We couldn't try to license with Siemens, for example, to create a Profinet device service. It would violate a lot of the open source environment that we're working with. So third parties can take on this role of providing these kinds of connectors to those kinds of protocols out there that either need some sort of licensing and or are in need of a little bit more of a complete protocol implementation than one that is provided by the open source group. So again, the icons you see at the bottom of the screen are just a representation of some of the device services that EdgeX already provides, but there are places to go and find additional device services should you need, or again, as we're going to cover here today, creating your own with the device service SDKs. I have a question coming in also on our QA session here. Is the REST device service actually an HTTP device service? The CoApp API is also RESTful. Yeah, good observation there, Anonymous. The REST device service is one where we're using HTTP. As a device service means, CoApp essentially is also REST-based, but just puts a little bit more, how should I put it? A little bit more standardization and CoApp apparatus around that same kind of RESTful or HTTP types of calls. So those two serve, if you will, very closely to one another, but depending on what your needs are, you may just want to be able to send straight REST with JSON, or you may want to use the CoApp API. So great question. Now, if you are going to use an existing device service, what do you need to do? Well, you need to run the device service of your choice. You need to create a device profile that describes your device, what data it's going to send, what types of commands or actuation you're going to need to perform with that device service. Creating that device profile is all about what's going to be in the talk next week. Provide for the device service configuration. In other words, not only do we have to provide for the profile, but where is this device service going to run? How does it communicate with the rest of EdgeX? Are there any kinds of parameters that you might want to set to allow for your device service to provide you some sort of connectivity to some other ingredients, say, for example, secret store to provide for secret configuration? Then you want to test the profile and the configuration with that running device service. Each of our EdgeX device services come with a number of profiles and configuration examples already. So there's plenty out there to help you get started. Next week's Tech Talk will also help provide for that as well. If you want to do a custom device service, if you want to develop your own device service, or even take one of our existing device services and extend it in some way, that's what this discussion here today is all about. Now, EdgeX provides a couple of device service SDKs, one in Go and one in C, when you want to create your own device service. Typically, your choice of SDK is usually going to be dictated by the availability of the libraries you want to use to communicate with the sensor device that you have a need to put in place. It may also be part of your choice as to which programming language you're maybe more familiar with. The idea here being pick the language that makes most sense for your use case for the connectivity to your particular device or sensor out there. Now, when should you look at creating your own versus when should you use one of the EdgeX already provided device services? Well, when your sensor device, your thing, speaks a protocol that EdgeX doesn't know about yet, then that's obviously a reason to create your own custom device service. Again, in the case of some of those proprietary types of circumstances out there, EdgeX can't provide those connectors. You're going to need to create your own, unless you can find a third party out there to help provide that for you. You may also want to add more features or capability to an existing device service. If you look at, for example, EdgeX's BACnet device service, it does allow for connectivity to all sorts of BACnet sensors and devices, but the BACnet protocol is astoundingly large. And EdgeX has done its best job to try and provide a good implementation of that, but would it be 100% of an implementation? Probably not. So if you need to add some capabilities to that BACnet device service in order to maybe fulfill more of the capabilities of BACnet, then you may need to dig into the SDK and add some functionality or essentially create some custom BACnet device services to meet your needs. You may also want a device service to be written in a different programming language. Yes, we provide Go and C SDKs to help you write device services in these languages, but maybe you want to create a device service in an entirely different programming language that we don't support today. You don't have to use the SDK. You will find that the SDK essentially sets up a set of scaffolding to communicate with the rest of EdgeX in an interface-defined way. If you understand those interfaces and you understand how a device service is constructed, you could choose any language. Don't use the SDK, choose your favorite language of choice and implement the interfaces in a way that allows for the device service to communicate with EdgeX, and away you go. This is obviously much more work. The SDKs, we think, provide a great shortcut to providing for your own custom device service. But in those cases where either maybe a library or your familiarity with a language dictates you go off in another direction, the opportunity is there. So if you do want to build your own custom device service, what do you need? Well, you're going to need a platform, obviously, to run both EdgeX and your new device service on. We like to say that about 1 GB of memory and 32 GB of storage on any kind of Intel or ARM platform that's 64-bit is going to meet your needs. We support all sorts of OSs, so Linux, Mac OS, Windows, you name it out there. But in terms of resources, you want to at least have some amount of memory and some storage capability. Largely the storage capability is there so you can download and get things up and running. You may find that based on your particular requirements, you can actually get away with much less than 1 GB of memory and 32 GB of storage. But that's a good starting point. And from there, your use case may allow you to go down in different directions. You will find that the platform requirements for EdgeX are listed out there in our documentation. You can take a look at that and see that essentially what I've just said is echoed there, but also some additional details if you need to know more about where you can run EdgeX. What else do you need? Well, you're going to need some tools to do any kind of programming or development. In this case, you're going to need an IDE or an editor. You can use a very simple editor out there. In fact, you'll see today that I'm going to use something like VI to do some of my editing. Not necessarily recommended for all complex type of programming environments, but any type of editor that allows you to get into and start to work with the code. You're going to need a Git CLI or some sort of Git capability to download and work with things like our SDK. You're going to need Make and or Go and or GCC if you're going to be building things like a C-based device service in order to help build and get those new device services created. You're probably going to need some sort of terminal or bash or shell in order to run certain commands like curl and or some of our means to interact with things like Git. And then you're going to need Docker or Docker Compose to run the rest of EdgeX. That's not an absolute requirement. You don't have to do that. You can run EdgeX in native form, but most people find running the rest of EdgeX so that your new device service can communicate with it is most easily done with Docker and Docker Compose. You're also going to want some sort of browser or means to access console and the EdgeX UIs. You need some sort of REST tool, if you will. You can use a browser. You can use something like Postman or curl, anything that allows you to start to access the APIs and also to run things like the user interfaces, EdgeX UI and console is helpful. Not an absolute requirement, but usually very, very helpful, as you'll see as we go through the demo here today. Again, the tools that you need, platform requirements, you could find all this in the EdgeX documentation. So docs.edgexfoundry.org. will allow you to pick up most of this information. I suggest you start at the Getting Started page. In fact, there is already a Getting Started page out there for developing your own device service. What you're going to hear today is essentially a second example, another approach, not necessarily approach, but another example of how to get the SDK and start to work and develop a device service. You can find another one out there in the docs pages. So you'll have a couple of examples to work with if you want to build your own custom device service in EdgeX. Okay, so let's get to the meat of it. How do we actually develop our own custom device service? Big picture, the big steps, if you will, of how to accomplish this. You're going to want to get and run EdgeX. I'm talking about the other services. A device service is a means to connect in your thing into the rest of EdgeX. So the first thing you need to do is get and run the rest of EdgeX. We're going to use Docker and Docker Compose to do that. As I mentioned, the easiest means of getting that up and running. So we'll take a look at that. Next step is you need to get the device service SDK. We have, again, two flavors, Go and C. Pick your favorite there. We're going to show you how to do it with Go today. Again, you don't have to use the SDK, but then a lot more work on your part to essentially put all the ingredients together to fulfill the interfaces where the SDKs essentially provide that scaffolding. And as you'll see, coding then becomes very minimal. Once you've got EdgeX running, once you've got the device service SDK, the next thing you want to do is actually create the new service. And the best place to, or maybe the fastest way to do that is use the example device service already provided with the SDK, as you'll see in my demo today. You'll want to modify the elements that are important to your service. And importantly, you need to incorporate the protocol communications for your sensor or device. So say, for example, you're creating a new device service. Maybe you're going to communicate with something like Profinet. Obviously, you're going to need to have that device service communicate through Profinet with your thing via the libraries and other capabilities for communication via Profinet with your particular device service. You'll need to modify the configuration. You'll need to create a profile. You'll need to set up the configuration for that device service so that it knows how to communicate with the rest of EdgeX and to talk to your particular thing. And then lastly, you'll need to run and test that new device service. And I'll give you a little bit of tips and tricks about how to do that today so that as you're looking at your service running, you've got a pretty good appreciation that it's doing what it's expected to do and communicating with EdgeX as one would hope as you move forward. So those are the big steps. Let's get into now how we actually do this. So first and foremost, as I mentioned, you need to get and run the rest of EdgeX. We call this hybrid mode development. That's because we're going to have EdgeX running in Docker and Docker containers, whereas our device service, we're going to run natively. We're going to build and compile and run things natively, in this case on a Linux system. So I'm going to do a hybrid mode where I bring up the rest of EdgeX through Docker and Docker Compose. When I do my development in say Go, as we'll see here in a bit, that Go device service then has to communicate with the rest of the services running in Docker. So you'll need to first download and get a Docker Compose file. I'm going to be using the Kamakura, the latest release, and I'm going to do so without security. I often recommend this as an approach to start things off. Once you get into security elements, you've got to provide for a lot more capability. You got to get certificates and everything. It's usually a place you want to get to, but you want to start with the simplest and lowest common denominator to understand EdgeX and then apply security on top of it. So I'm going to get the Docker Compose file that provides for Kamakura release without any security. I'll remove the services that I don't need from that Docker Compose file, like, for example, other device services, like the virtual device service. I'll maybe change a few things in that Compose file, and then I'll run it with Docker Compose upd. If you didn't attend the introductory EdgeX tech talk, please do so, and you'll get a lot of the information about how to do just what I'm explaining here, how to get and run EdgeX via Docker and Docker Compose. Now remember, in this hybrid mode, since we're running the rest of EdgeX in Docker and Docker Compose, it runs on a Docker network. Whereas your service, the device service that we're going to create, is going to be running natively. It's not in that Docker network. So one of the things to remember as we're doing this kind of hybrid development is you have to get your native service communicating with those containers on the Docker network. That's going to require a little bit of a change inside of our configuration. Nothing that is going to be very difficult, but I'll show you how to do that. Just keep that step in mind. This is one of the most often asked questions I get in Slack is, why won't my service communicate with all the other services that are running in Docker? Well, it's typically because you've forgotten the fact that you're outside the Docker network. So we'll make sure to address that as we take a look at our demo. If you're wondering more about how to set up kind of a hybrid development mode, even maybe doing so outside of building a device service, there is a hybrid development page inside of our documentation that'll help you with this, because you may find that there are other environments whereby you want to work on a piece of EdgeX outside of Docker, but you want everything else to run in Docker. This hybrid development page will help you with that. So let's take a look at how we get and run, quote unquote, the rest of EdgeX, and then we'll start building a device service. So our first step, and let me bring up a couple of things here. I've just got a Linux environment here. And the first step I've got to do is I've got to get and download the Docker Compose file I want to use to run the rest of EdgeX. Now, with regard to that, if you go out to the EdgeX website, GitHub, you will find a repository out there called EdgeX Compose. And if we go to the EdgeX Compose repository, you will see all the various Docker Compose files that we can pull down and use for any of the versions of EdgeX. Again, I'm going to be using the latest. I'm going to be using the Kamakura release, and I'm going to use the Kamakura release's Docker Compose file with no security. So all I really need to do is click on that. Make sure you get the raw. You don't want all the HTTP characters in there, but get this Docker Compose file into your system, and that provides the basis from which you can run, quote unquote, the rest of EdgeX. Now, I've already downloaded that particular file into my Linux environment. And if I take a look here, you can see there it is, the Docker Compose YAML file. If you want, we could take a quick look at that. If I take a look at, you will find that the only thing that I have done with this particular service is I have taken out a number of the existing device services. For example, device rest, I don't need it. I'm going to be creating my own device service. I've also done things like changed the access control. I've made it so that everything is completely accessible from anywhere. Most of these ports have a 127001 signifier in front of them to help protect it in terms of security. I've taken those off just for demo purposes here today, so I can show you some of the various APIs and things. But really, it's just a matter of getting that Docker Compose file and being able to bring up the rest of EdgeX using that Docker Compose file. This Docker Compose file and all the code I'm going to be showing you here again today is on our wiki site, so you can take a look at exactly all the pieces that I am showing you here today on screen. So now that I've got my Docker Compose file and I've got it in a shape that is ready to go, all I need to do is do a Docker Compose up -D for daemon, so I'm not constantly looking at long files. And that's going to bring up my Docker Compose, my EdgeX environment in Docker, all of the various services minus any other existing device services. I don't care about any other device services because I'm going to create my own. If you'd like, you could even test that things are up and running correctly. You can bring up a browser at this point and you can go to the console page for that service. You can bring up the user interface page and make sure that EdgeX is running from both the services as well as all the capabilities out there. And in fact, you can see right now it's got 0 device services. I've got 0 devices. That's because that's what I'm about to do, create my own here. Okay, what's next? So I've got Docker Compose that's brought up all of my EdgeX environment. I've tested to make sure it's all up and running. The next task that I have on track here is I've got to go out and get the device service SDK. Again, the SDK comes in 2 flavors, Go and C. In this particular environment or in this particular demo, I'm going to use the latest, the Kamakura version. How do you get the device service SDK? Again, let me go back to the EdgeX GitHub page. And if you take a look, let me back up here. If we take a look at EdgeX, I could do a simple search for SDK. And you're going to find several SDKs out there. You're going to find the App Functions SDK, which Lenny Goodell covered actually this past week. You will also find out there the Device Service SDK in both Go and C. So pick the device service that is going to meet your particular needs and simply do a clone of that particular device service SDK. So the clone command will look something like this. You want to get clone depth. I just asked for one particular, if you will, the depth of one branch down. I'm going to get the version 2.2.0, and I'm going to get it from, in this case, the device service SD code get location. If I ran that command, I would clone my SDK right into my directory. Now, I've already taken the time to do that since that takes a minute or two to get down and you guys don't want to watch cloning going on, but you can see already here, I've got the device service SDK go there. If I go into that particular directory, what you'll see is there's an example folder there. This is the example that already comes with the device service SDKs. And this example is going to help me start up in the creation of my new custom device service. If you will, it's a starter kit for how to develop your own device service. So we're going to use that to good effect here in just a bit. Okay, with that in place, what's the next step? I've got EdgeX up and running, and I've got a clone of the device service SDK, in this case, the Go version in place. What's up next? Well, the next thing I need to do is actually create a new device service from that sample or from that example code. When I create the device service, I'm going to want it to communicate with a sensor. In this demonstration, what am I going to do for that? Well, my laptop actually has the capability to give the CPU's temperature. So what if I wanted to create a device service that gave me the temperature of my laptop? Maybe I'm doing a real world scenario where I want to test the temperature of some sort of device that I'm actually out there on. In this case, I'm going to use that as a means of demonstrating pulling data off of a sensor. In this case, the laptop that I have. You can actually do this if you've got a Linux laptop. You can actually cat the temperature from your particular environment, and it's going to give you back, in this case, a big integer, which is the number of degrees in Celsius that your particular CPU is running at. In this case, it would be 53 degrees. It doesn't do as a float, so it's actually 53.0. If you took a look at this, you can find the documentation out there on the internet, but that's going to simulate my sensor for the purposes of this example. So in creating a new device service, that in this case uses my laptop as a sensor, what am I going to do? I'm going to create a new working directory out there called device laptop temp. Call this whatever you'd like, but give it some sort of name that represents the type of thing you're connecting to. Then once you've got that folder created, you want to copy the elements of that example from the SDK into your new folder. And then you're going to want to do a little bit of cleanup. There are things like a README file that you don't need and some movement of files around that you might want to make just to make things a little bit simpler for yourself. So let's go do that now and actually start the development of this new device service. So let me go back down to my root directory. Again, I'm going to make a directory that I call device laptop temp. That's going to hold my new device service. With that new folder in place, now I want to start to copy elements out of my SDK and into that device laptop temp folder. In particular, I'm going to create or copy the Makefile from my example. We're going to need to build, so we're going to need a Makefile. I'm also going to need a number of the Go files that are out there in the SDK. So in this case, I'm going to take the version Go file and gives an indication of what version I'm using out there and copy that into my desktop laptop temperature device service. And finally, I'm going to take a lot of the example code that actually provides for this device service and copy that into my device laptop temp. Now we'll take a look at that example code. That's the critical piece. We'll take a look at that example code and what code we need to change inside that example here in just a bit. But first and foremost, I just need to get that code into my new device service folder. So now if I take a look into my device laptop, I'll see that I've got a number of things already there. I've got my make files, I've got my version file, I've got the code. It comes in 3 folders, command, config, and driver, all of which we're going to come back to in a bit and work on. There is a bit of cleanup you can do. In fact, at this point, what I typically do, let me back down here. I'll do some cleanup, like I will remove some of the scaffolding folder structure that's in there. Oops. Sorry, everybody, copying and pasting errors here. So I'll remove what's known as the device simple folder. It would be helpful if I am in the right folder. Let's try that again. There we go. I'll get rid of things like the README. I really don't need the SDK's README file inside of my new device service. And I'm also going to remove any of the folders that I no longer am needing. This is all optional stuff, but it just helps to kind of clean up and make things a little bit simpler out there as we take a look at the code base. Again, these are things you'll see in the code that's in the wiki page out there if you want to take a look at the device laptop temp example that we're creating here today. All right, now I've got the code in place. What's next? Well, I'm going to need to do some work on my device service. I'm going to need to code this new device service. I've copied the example, but obviously I needed to do some work. In this case, communicate with my sensor being my laptop CPU temperature. I'm going to need to update the Makefile to build this new device service. I'm going to need to code what's known as a driver. This is the critical and important piece of this new device service. The driver is what makes communication possible of our device service with the thing underneath the covers. It's what handles how to do the get and the set, if you will, a collection of sensor data and the actuation. The scaffolding is already there. I just have to tell it how to do that with my sensor. Much more is possible as we'll take a look at, but we'll keep it pretty simple today and make sure we can do the gets and the sets. And then I need to build, or if you will, compile my device service to make sure that everything is up and running. So let's take a look at how to do that. First off, in terms of updating my Makefile, I need to change the name and the location device service. The example obviously is dealing with a sample directory out there that doesn't exist. I want to make sure that I change it for my particular device service. I'm going to change my Go flags to make sure that it points to my service and the service name that I'm using. You want to tell it where you want your executable to be located. And you optionally may want to update the Docker file locations if you plan to create a Docker container or Docker image, if you will, from your particular service. So let's go take a look then at my Makefile and how we do this inside of this environment. I'm going to bring up a simple editor here. I've got myself Visual Studio Code editor here. Let me sign in so I get access to my code base. And it's going to go out and bring me back to that directory, my device laptop temp. And we can see right into that code base here. And importantly, what we're going to want to do is edit the Makefile at this point. So first thing I want to do is make a couple of changes to my Makefile. This is the Makefile I got out of the sample SDK. So I got to change some things here. We're no longer dealing with the example. We're actually going to be dealing with my actual device service. So I want to change this. I'm going to change it to deal with where my particular device service is going to be, device laptop temp. That's the name that I gave it. And I'm going to put that in the command folder. You'll see where the command folder is here in just a bit. I'm going to need to change my Go flags here since we're working with Go. I'm going to need to change the Go flags here to also point to that same location of where my particular code is going to be. So device, laptop, if I can spell correctly, temp. Let's do that in both cases here. Okay, so I've changed my Go flag so it knows where to find my code. I'm going to change also where I want my code when it's compiled to actually go. So in this case, I'm going to change it from what's in the sample to say, well, where I want my executable to actually go is command device laptop temp. And you can see that matches my microservice name up here as well. And I'll have to change my code here too to put this in command. Okay, so I think I've got everything there. I could optionally change also if I was going to deal with creating Docker files, and I should say Docker images for my service. I could also change this. For the time being, I'm not going to deal with that today, but you could go back to the Makefile and make changes there to make sure that once you've got your device service up and running and working correctly, you could actually make the changes to Makefile here to actually create a device service image for your particular device service. Okay, so let me save all that. Now, if I come back to my, my Linux terminal here, what I could do is run a quick test to make sure that my Makefile is working properly, even though I haven't coded the device service yet. The only thing I changed was the Makefile, and it's got all the sample code already in there from the SDK. I can at least make sure that things are correct and I can actually build my device service. So first thing I have to do, if you're familiar with Go, is you need to initialize your Go environment. You need to essentially tell it how to get things like the libraries. So I'm going to initialize or do what's called the go mod init on my particular folder here. Whoops. What have I gotten wrong here? Let's try that one more time. Maybe I copied incorrectly. Oh, okay, it's already existing. And so now I'll do my go mod tidy to make sure that all of the packages that my particular service is running are also available. Or if you will, the SDK is using a number of libraries out there, and it's pulled those in so that when I actually build, it can take advantage of those libraries. So those are just Go development things. If you're familiar with Go, it's essentially getting my infrastructure and my packages ready so that when I build my service, away we go. Okay, and with that in place, now I could test the build. I can do a make build and make sure that the development environment is all up and correctly set up. My Makefile is all correct, and at least the structure of my new device service is correct. In this case, it is now build my executable. If I actually go to that CMD folder, and I can actually see it there, device laptop temp. Now this device laptop temp executable at this point is not running any of my code to actually perform the connection to my sensor and bring back devices and sensor data from my sensor. Remember, all we did is set up the scaffolding at this point. Now we're going to go code the actual device service itself. So how do we do that? Let's go back to our slide set here. So I've gotten the EdgeX environment up and running. I have gotten the SDK. I've created a new device service, and I've actually got the Makefile set up to build my environment correctly. So now I've got all of my infrastructure in place. Next up, we've got to code the driver. The driver is the name that EdgeX Foundry uses for what is actually driving or communicating with the sensor or device out there. We'll need to do some changes here. We'll need to change what's known as the service name. I want to give it a name unique to me. In this case, that device laptop temp will probably be the name we'll give our service. We'll go into the driver.go file, and we'll define things like what service operations we need to have performed and how to communicate and exchange with a particular sensor device, using the protocols and the libraries necessary to do that. In this case, I've got a library that helps me communicate with the OS underneath the covers to get the temperature off my laptop. But if you were dealing with Profinet, this is where you'd have to use things like Profinet libraries to communicate with your Profinet sensor. Much more is possible in this area. We're going to keep it simple at the start, and that is we're going to go into our driver and have it communicate how to get data from my sensor. We'll do that through a function called handle read methods. And we'll also go in and make some changes to what we call the set function to be able to set or communicate actuation commands back down to the sensor device. That's done through what's called a handle write commands method. And we'll take a look at both of those, and you'll see the general structure where you can do other things here in terms of the more is possible in just a bit. Importantly, what we have to do is tell this driver how to communicate what we call device resource information. Device resource is the name that EdgeX gives to a particular piece of information, an attribute, a property, whatever name you want to give it, that the particular sensor or device is going to communicate one way or the other. In this case, my laptop, the one device resource I'm interested in is the temperature, or more precisely, the temperature of my CPU. But you may have a sensor device that has just thousands of device resources. Each piece of information you're trying to get from your sensor device is considered a device resource. So inside this driver, we need to code that information about, through the protocol of choice, how you get that device resource either get or set inside of the EdgeX device service. That'll become more clear here as we take a look at our example in just a second. Okay, so let's go looking at how you actually code the driver now and get your new device service communicating with a sensor or device of choice. So I'm back to my environment now. I've got, again, the shell of my environment up and running. We know it builds correctly. Now we need to actually go and code this device service. Notice, first of all, that there's a main.go file in this command directory of the device laptop temp. Again, we copied this over from the example code. Very first thing I need to do is make some modifications to that particular file. So in my command, in my main.go, I'm going to make a couple of changes. First off, notice that it's got a name called device simple. This again came from that example. We're going to want to change that. We're going to want to change that to the name of my service, in this case, device laptop temp. We're also going to need to provide for some packaging here. What I need to do is change out the names of some packages, some imports that came from just the sample, and I need to add a couple of new ones here that I'm going to be providing as part of my work inside this device service. I'm going to tell it, hey, use the code inside device laptop temp, and specifically use the driver that I'm about to specify. So I'll make those changes in main.go, so pretty simple work right there, just to essentially get my device service started to be coded, give it a name it likes, and give it the location of the code in terms of imports, where we're actually going to find things like the driver. Notice it also references the SDK startup package. Leave that in place. Whatever device service you're building in Go, you want to leave that reference in place. That's a reference to the other SDK scaffolding that the device service needs to use. Next up, what I want to do is now go and code the driver. Inside of the driver folder, you're going to find a scaffolding file already called simpledriver.go. You could change the name of this. We're just going to actually use this example and change some code inside of it to actually do the things we need this driver to do. You're going to find that there are lots and lots of methods inside of this particular folder, or I should say file, this Go file. There's an initialize function. There's a process custom configuration. Handle read commands. That one's going to be very important to us. You're going to find a handle write commands. These are all the things your device service can do. What do you want to do when the device service stops? Is there something you want to communicate to the sensor device? Well, if you did, you'd need to code it here. If you're adding a device, what do you want to communicate with that device? You would add that kind of code here. Notice there are lots of functions in place. You want to discover a new device? You do that through this scaffolding function. All these functions are means to be able to communicate with your sensors or devices in the scaffolding, if you will, in the interfaces set up by the device service SDK and EdgeX Foundry. The two that we're going to be most concerned about with today are handling read commands and handling write commands, the get and the set of this SDK development. Now, in this case, again, I've got some code in place. I'm going to just copy and paste it. We're not going to spend a lot of extra time here kind of focusing on this because your device, your sensor is going to be very different. But I'm going to rip out all the existing code that's in place in this handle read command. And I'm going to put a simple thing in place. Oops, let me leave that one line there. I need that one. I'm going to put some code in place that says, what I want to do is when the handle read command is hit by EdgeX, this is the command that's getting requested if I need to get data from the sensor. When I do that, what I'm going to do is actually going to call on my Linux system and a library provided out there, which we'll see here in a second, that communicates with my Linux system to get the temperature of my particular device, of my laptop. Notice we're using the term device resource name here. We're going to treat temperature as that device resource, as that attribute, as that property of the sensor device we want to communicate with. And I even give it the instructions about how to do this. This is an execution of a Linux command to actually get that data off of my laptop. Here's where things get sticky. Here's where things get to be very precise in terms of your communication with your sensor device. I can't tell you how to communicate with your sensor device. I'm just showing an example of how to communicate, in this case, with my laptop to get that data. Here's where your libraries and your protocol code have to come and play to communicate with your sensor or device of choice. Once I've gotten that particular piece of data, in this case, the temperature, off of that the laptop, I'm going to embed that in what's called the new command value. Essentially, I'm going to return this value to EdgeX. I'm going to put it on a message and send it into the rest of EdgeX. Now, all that scaffolding code is really already made available via the SDK. So all I have to really do is create a new one of those and take the output and put that in terms of its temperature. I'm going to convert it from string into some sort of integer, but I'm going to take that temperature, send that in as an int64 into this new command value and make that available via my SDK to the rest of EdgeX. That's all I really have to do in order to be able to get a sensor value out and pass it into the reg of the EdgeX environment. Again, your code in this particular driver will change based on your sensor device, based on the libraries you have to communicate with it. But that's how simple it is to start to work with the scaffolding in order to communicate and get code in place to communicate with your sensor device. I could do the same thing in terms of write commands if I needed to be able to write. If, for example, my laptop allowed me to update the temperature of my CPU, wouldn't that be fun? I would do that kind of work here in the handle write commands in a very similar way. Now, one thing I'm going to need to do in this code in order for my system to work properly, in order for my device service to work properly, is I need to give it access to, or if you will, import of a particular package. There's an OS exec package out there in Go that allows me to communicate with my Linux environment. Here's where you would add the imports for your particular protocol of choice in your communications with your sensor device. Okay, let's save all that. And let's see now that I've got all of that code in place. If my particular environment is set up correctly, I should be able to do a make build, and I should see all of my code compiled. And again, the device service has now been built. If I go back into command, I'd actually see, again, the device laptop temp executable has been created, but now it's coded to actually get data from my particular device or sensor, in this case, that simulation using the CPU from my laptop. What else has to change? Well, I've done the coding part, but there's still a few other pieces that I need to get done in order to have my device service completed. I've got the code, the driver coded. Now I have to configure the device service. I need to run the new device service. I need to configure the device service with a new device service profile. Again, you'll learn more about device service profiles next week. And I need to configure the device service to have some information about how to communicate with the rest of EdgeX. How do we do that? Let me do a couple of changes here that will help us be able to do those few things. So inside of the command repository, you will also notice a folder, I should say. There's also a res folder. I'm gonna go to res now. And first thing you'll see there is this configuration TOML file. The configuration TOML file is what provides this device service or any service inside of EdgeX information about how to communicate. For example, log levels, what log level do you want to capture, where to communicate with the rest of EdgeX, how to get connected to and communicate with other elements like core metadata and core data. All the information is in there. I need to now make a couple of changes in that environment so that I can now actually work with the EdgeX environment that I have in place. So I'm going to make inside of my res configuration TOML file, make a couple of changes. First of all, I'm going to change the log level to debug. Always a good idea when you're creating a new service. I also have to tell it to communicate with the rest of EdgeX. Now, I do that in place of here, I've got to change the host. I say I'm running on localhost right now by default, but remember the rest of my EdgeX environment is in Docker. So I'm actually going to change this to be the address of my laptop where I'm running my device service. So therefore the rest of EdgeX knows where to find me. If I said localhost, remember the rest of EdgeX is in Docker. It doesn't know what localhost is. So that's a big tip here, gang. Make sure your host is set up to be the IP address of your particular service, in this case, my device service, so the rest of EdgeX can find it. Once I've got those changes made, my configuration is ready to go. I now need to provide a profile. A profile is what defines what attributes, what device resources you're going to be communicating back and forth between your device service. Again, more on this next week. Notice that it's built up to deal with a sample. The sample obviously came from the SDK. I'm going to put in place, I've already got a device profile already in place. So I'm going to copy what's in, let's see, my backup. Let's see, it's simple driver YAML. I'm going to copy that to my profiles directory here. So I'm just going to copy that already in place, and then we'll take a look at it. Again, more on this coming up next week, but a profile is what defines what particular device resources you have. Temperature being the one that I'm dealing with, my laptop CPU temperature, and we're telling it that that's a int64, that we're going to be able to read and write it. That's actually a bit of a misnomer. We're only going to be able to read it, but in cases where you did need to read and write it, you'd have to specify that. And we're telling it the unit of measure here is in Celsius. So we're communicating with my device service what type of information through device resources are going to be communicated with my sensor device. I'm also providing some information about the name of my device profile, who's manufactured it, the labels, things of that nature. This is all metadata that's helpful to, once I have a system up and running, understanding more about what my device is all about. So I've made changes now to that. Lastly, I need to make some changes to what's known as the device configuration. I have to tell my system what particular device I'm actually running. In this case, I'm going to skip to the chase here a little bit and make this a little bit fast. I have to tell it what my device name is going to be. What name do I want to give this device? I'm going to call it my laptop device. I'm going to tell it what profile I want to use. In this case, we've already seen the name of my profile I just showed you. We called that the laptop device profile. I can give it some description. I can give it some labels. I want to tell it what to communicate with and when to collect data from it. I'm going to collect data every 5 seconds. And what data I want to get is the temperature device resource. I could take off that other auto event to get any other additional data. I only have the one device resource in this particular laptop device service. So now I've configured my device service to communicate with a specific device. This is called one we call laptop device. I've told it how to do that through my device profile. I've told it how often to do that. Every 5 seconds, get the temperature off of my system. With that, I'm going to save the file, and I believe we are now all set and ready to go. I've got my profile defined. I've changed my configuration. I've told it how to actually talk to my particular device. I'm now ready to actually run my new device service. How do I do that? Again, I'm running in not secure mode, so I'm going to set an environmental variable to tell it that I'm not using a secret store or any secrets. I'll then actually begin my device service. I'll check the logs, I'll check the UI, and I'll check metadata to make sure everything is actually up and running. So let's go do that. So first and foremost, I will tell my environment. Let me back down to my command directory where, again, my device laptop temp, my executable is there. And I'm going to export out this environmental variable that says, hey, I'm not running in secure mode. So don't bother looking for a secure store. And now I should simply be able to run my device laptop temp executable and communicate that into my environment. Now you'll see I'm getting debug information. You can see here in the log file that it's actually communicating with my laptop at this point. It's communicating with EdgeX, and it's actually starting to send in data. In this case, we can actually see it's sending in temperature data from my laptop that's suggesting that the data is being collected from my laptop, and it's sitting at about 55 degrees Celsius. Let's see if that's actually the case, and if the EdgeX is actually up and running with my new device service. I could do that through the UI. If I take a look at my UI and I refresh the dashboard, I now see, give it a second here, that I now have one new device service. That's my device laptop temp. And I see it's connected to one device, my laptop device. We can actually see my profile out there. If I'd like, I can actually go and take a look at the data streaming in from my new device service out there. Again, this is the temperature coming off of my CPU, and you can see it's reporting from device laptop that the Celsius value for my laptop is coming in around 53, 54, 52 degrees Celsius as it collects it every 5 seconds. So that, ladies and gentlemen, is a quick walkthrough of how you use the SDK to create a new device service, one that communicates, in this case, with a device laptop to get its CPU temperature, but it could be to any particular protocol and any device out there known to man. Bring that data into EdgeX, make it available, and also now be able to do things like issue commands on the device. If I had my device service set up to actually communicate back down, I could actually issue commands to set, for example, the CPU temperature, or to issue commands to actually get that temperature. I can actually try that and see that I can issue a command back down to my device service through EdgeX to get the Celsius temperature off that laptop. Let me wrap up here quickly as I've only got a minute left. So we've seen how to get the SDK, how to use it to build an SDK device service, run that device service, and get it communicating with EdgeX. If you'd like more information, please use our docs page, docs.edgexfoundry.org. You'll find some samples out there to create new device services already exist, both in Go and C. You can find more information out on our Slack channel or ask questions in our device service channel if you have some issues as you're building your own device service. This particular talk, as well as all the others in EdgeX, can be found on our YouTube channel. Search EdgeX Foundry on YouTube and you'll find all of our talks out there, our tech talks. Code is available in github.com EdgeX Foundry to include our 2 SDKs. Also to include things like example device services you can use to also see and use what you've learned here today. Use social media to communicate with us. We'd love to try and answer your questions where possible. Remember, next week, we'll have a tech talk on device profiles, learning how to build up those device profiles to communicate with existing device services. And at the end of June, we're going to see a talk from Canonical on how to use snaps to get your EdgeX environment up and running. I'll take any kind of questions. I'm looking here at my chat channel in my Q&A session. It looks like I've answered all the questions, but I do have a couple of seconds here to try to address any questions anybody has. Please feel free to drop those in place. By the way, if you do have any questions while I'm waiting for any kind of question that does come in, and it's past our Tech Talk time, then just email me at info@edgexfoundry.org. Happy to take any questions at any time. Of course, also use our Slack channels to ask questions as well. Folks, I don't see any other questions coming in. So with that, I'm 1 minute over. So I want to end this talk today. I want to thank you all for attending the Tech Talk today. Hopefully it's helped you learn how to build a new device service in EdgeX Foundry. Wish you all the best. Come join our community and look forward to hearing from you soon. Thanks, everybody.